And on today's episode of Building Robotic Homemade Body Exoskeleton Body Armor, we do just that. I am pissed, and you should be too. It was the 2020s, and I'm sure somewhere along the line, someone promised you and me that we could go to Target and buy basically an Iron Man suit, or Walmart, buy the Mainstays version. You know that the Mainstays robotic exoskeleton suit would just be the biggest hunk of shit on earth. It'd probably have one of those labels on it that says it causes cancer in California. Actually might be the name of the robot. California Cancer. It just says it on the front. We've derailed. So I've seen people building exoskeletons before where they basically throw a motor here, throw a motor here, throw a motor here, throw a big one right here. And it just kind of makes these weird movements that don't really kind of jive with how we want to jive together. I was wondering if we could approach this a little bit differently with a whole bunch of little tiny motors that shrink and contract, and that's how you get your movements. Well, my initial idea for the prototype made sense in my mind. It didn't really make sense in real life. My original thought was to make a piece of domed armor. Underneath that, I'd have a little square rectangular thingy-majigger with a whole bunch of servos in it, and that would move around. We could connect the armor to other pieces of armor, and it would move around kind of like a weird armor blanket on your body. Blanket body. But I kind of didn't think this through, and the pieces just kind of jiggle on top of each other, and when you go to twist and move, they kind of just it didn't work. To fix all my issues in life, I wanted to design a little module that could collapse in on itself or expand based on a servo's movement. So that's what got me to here. I wanted to make the design modular, compact, fairly easy to print on our Creality Ender 3 Pro printer, and just use some BBs as bearings so there wouldn't be a lot of grinding in plastic or having to buy metal bearings to weigh this thing down. And that is what brings us to its final form. It gets better. There's another form after this. Just keep watching, please. And then I took 6 of our individual sliding models, pog-glued them all together, basically, in CAD, and then threw them on our arm joint to recreate an elbow. My original idea was to recreate this type of movement, but it could do this kind of movement just as easily. So I think if we put a red wig on this, took it to Wendy's, they could probably hire it to flip burgers. We put a wig on it, smooth some of the edges. We could also make it a sex robot. Either way, I want to cover both of those options with Chili. For our testing today, I actually set it up on the same rig we used to test our magnetic ball and socket joint robot. And if you're interested in seeing more of that project, I'll link it down below in the comments and description so you can check it out. But get subscribed because I've got some cool updates planned for that little guy, and maybe it'll get better. Maybe it won't. It can only go up from here. I wouldn't make a video about making it worse. Or would I? Now we're going to test out just how strong our Dollar General Iron Man suit is. In our 6 SG90 micro servo setup, it kind of acts like a bicep. But if we were to move the pivot point, add on a few more on the backside, it'd act like a tricep. So that's a good way we could add some more power down the road. So there we go with our first round of testing on a robotic exoskeleton arm thingy. We can get about a pound and a half. Crank the voltage all the way up to 7. She'll do that a couple of times. You get 1.6 pounds. So that ain't half bad. But now you and I have got to buckle down on our project. We've been kind of slacking, and we need to figure out the next revision. One of the issues I've noticed is that when the gear spins on this, and if it kicks over a tooth and kind of skips, well, it won't ever reset itself, and you can actually just pull this piece all out and bearings roll across the floor again. If this was under a lot of stress, it just ain't gonna fly. I want to revise our design, so stay there. I want to revise our design. That way, if it was to skip or move or get forced, it will never actually disconnect or fall apart. Or some sort of micro switch that knows when it's all the way open, closed, and it can rehome itself, however we want to go about that. But what should we do next? Should we concentrate on making each little module as compact as possible? Should we make it as strong as possible? Throw a comment down below and see what the next one turns out like. We're already losing BB. Okay, that one's gone. You're really gonna roll across the entire floor while we're filming? That's fine. Just keep rolling. Okay.